we reconvene the afternoon session, we would like to first have an announcement from Mark Scher. Mark Scher is the president of the student chapter AIA. Mark.
Thank you. The small announcement is that tonight the students are going to conduct a discussion between the professionals and the guests and the students, and we're going to pertain it to the Energy Symposium and to our curriculum. It's going to begin at 7 after dinner, and we'd like to invite everyone back to help us, do what we can as far as our curriculum and as far as accumulating the information from the Energy Symposium so that it can be used as recommendations for the college. The last thing I'd like to say on behalf of the students is I'd like to thank the professionals for their presentations and their time spent. I'd like to thank the guests for their interest and comments, and I'd like to also thank the faculty and administration for their hard work on the symposium. Thank you.
Is Steve Butterbaugh back? Good. Thank you. Our next speaker will be Steve Butterbaugh, project architect with the McGuire & Shook Corporation, Architects and Engineers, Indianapolis. Steve will principally be talking about a method of studying energy use of buildings. He will describe the process they've used in studying about 50 buildings at the Fort Benjamin Harrison, Indianapolis, Indiana. Steve.
My purpose is to present the method used to study the energy consumption and ways of reducing that energy consumption of 59 buildings at Fort Benjamin Harrison in Indianapolis. But first I want to set the wider context in order to properly locate the study method. In the summer of 1976, the Army Corps of Engineers hired McGuire & Shook Corporation to study and write a report on methods of energy conservation for the 59 designated buildings. The scope of the work included these things: making a single-line drawing of each floor of each building, indicating the use of each space, observing and reporting on the general condition of each building regarding maintenance and repair, describing the existing architectural, mechanical, and electrical systems of each building, proposing and studying changes to the existing buildings we thought had potential for saving energy, recommending those changes which were feasible, constructing a list of projects in the order of the least payback period, not to exceed $1 million per year for 5 years. The buildings we studied were of varying types. Most were brick. I think 2 were wood, of which I have no pictures. Many of the buildings were built early in the century, such as this post office, which was originally a train station. But they ranged across the time spectrum. One building was in the finishing stages of construction as we surveyed it, this dormitory. The buildings were small, such as the post office, which I showed you, of 2,200 square feet, and this warehouse of 6,500 square feet. However, some of the buildings were quite large, such as this classroom building of 307,000 square feet, and the Army Finance Center of 1,630,000 square feet. This is the Army's largest building. To walk around this building to observe the status of the exterior was to walk 2/3 mile. The uses of the buildings ranged over the entire lot of possibilities of an Army community. Office buildings, educational facilities, retail store, transportation center, grocery store, foodstuffs warehouse, a courthouse, a jail, a men's dorm, and a restaurant school. Others were a movie theater, a playhouse, a bowling alley, library, mess hall, officers club, NCO club, veterinarian, craft and hobby center, pump house, motor pool workshop, appliance repair shop, gymnasium, clothing store, and hospital. But through all this variation, the method of study for each building remained the same. In the summer of 1977, McGuire and Shook prepared an exhibition board for the American Hospital Association's convention in Atlanta, Georgia. We wanted to advertise the fact that we could do energy conservation studies. But the question was, how do you communicate that idea with any credibility? Most of the exhibits were of buildings that had been built. Floor plans and photographs of an actual building speak for itself, but the picture of a report says nothing. We finally settled on the straightforward approach, displaying the process of our studies. We used Holly Army Hospital at Fort Bend as the means of concretizing the process. Before I go on, I want to explain how the board is organized. Of course, the dark portions are the title and our firm name. The gray portions are client concerns and actions, and the white portion is the study process. In the study process, each ellipse is a large step in that process. The next smaller type are the sub-questions under that step. And then the small type, which you can't read, is the actual Holly Hospital, which concretized those general statements. You can read it in real life when you're close to it. Our appeal to the potential client was to identify his fundamental questions and to appeal to his self-interest, to be able to make a rational, resource-saving decision about an increasing problem, energy. These questions are, what energy-conserving measures can we take? If there are several changes, in what order should they be made? When will the energy savings pay back the cost of making a change? As a point of clarification, we as energy use studiers cannot answer those questions, nor can the client. But together we can answer those questions. An energy study must produce 3 types of information before those questions can be answered. And they are answered by looking at those types of information in the context of the finite, limited reality of the client's financial status. A client has a limited amount of assets, either in money or in less liquid form, which can be spent on making a change in his building. Some projects could save a considerable amount in operating costs, but the client could not afford the initial cost. He may be able to borrow the money to make the change, but to know if that is wise, among other things, he needs to know how much he will save in energy operating costs each year. If he could make his payments on his loan from the energy savings, then there would be no net change in his budgeted operating costs. But sometimes the energy operating cost savings are less than the loan payments. So to make a change will require more income to cover the deficit or a shifting of expense items. Here the payback period is the useful bit of knowledge. With it, he can gauge how long he will have to bear the extra burden before he will be better off. The initial cost, the operating cost savings, and the payback period constitute the information the energy study can provide so that the client may make a rational contextual decision. He is then able to set up a course of action to make his building more energy efficient. Now let's proceed to the actual study process. The first step is to survey the building. The first portion of this step is to survey the written documents of the building. In this case, Holly Hospital. We obtained the working drawings, specifications, and the history of the building's energy use. The latter included the electricity bills. We were very interested in the formula which the electric utility uses to determine its charges. In looking at the plans and sections on the working drawings, we were concerned about the nature of the building's skin. What is it like and how much does it vary? We had the plans and elevations reduced to fit on an 8.5 by 11 sheet of paper, and we color-coded the elevation to indicate the various types of building skin. We drew up the various wall and window sections so that the U value could be calculated and that we could communicate in our final report the nature of the skin. With this level of familiarity of the building, we went to the real building to see how it corresponded to the information we had. Walls were often shifted or removed. Windows and doors were often removed. Exterior walls sometimes had insulating materials such as paneling added. Upper floor ceilings were often recently insulated. Sometimes dimensions were different than what was shown, or an addition had been made to the building for which we had no written record. Storm windows or thermal pane replacement windows were sometimes added. In addition to the physical changes, we would record the use of each space. We would talk to the occupants to see if they had any complaints concerning heat, cold, or light. When we returned to the office, we calculated the different areas of the building, skin, and made the single line drawing of the current floor plan with use indicated thereon. If you look up there, you'll see the single line drawing is to the left. The single line drawing went to the mechanical and electrical departments, who were in the process of familiarizing themselves with the written documents of the building. The plan became one of their data collecting worksheets. When the mechanical and electrical and plumbing people went on site, they normally began their survey with a general walkthrough. They looked for problems such as overheating or overlighting. If in the dead of winter a window is open for a refreshing bit of air, then it is likely the heating system is overheating at that point. The second time around, these people looked at specifics. The electrical man measures light levels at the workstations and records the number and types of fixtures. The plumbing man is concerned with hot water temperature at the faucets and the flow of water in the showers. He looks at the kind and size of water heater and pipes. The mechanical man is interested in the type of system used for heating and cooling. He measures the velocity of the air coming from the air handlers. He checks steam and air temperatures, the RPMs of fans, and the amperage of motors. He finds out the hours of the day the building is in use. Now we have our database and can move to step 2. We will analyze what we have. The architectural department looked at the building's skin. Are there large heat gains or losses which can be made smaller by architectural means? The plumber sees if the water temperature and flow are appropriate. The electrical man looks at light fixture efficiency and the correspondence between lighting levels and the use of space. He checks the electrical utilities rate formula. Is there a peak load factor which will keep the electricity bill high even if some reductions in kilowatt hours are effected? Can that peak be brought down to reduce the peak load factor? The mechanical man looks at the use of the mechanical system in relation to the occupancy of the space. If the system or part of it is running continuously, can it be shut down except for the 9 hours per day when people occupy the space? Can the system be modified for better efficiency? Is there an alternate source of energy? In the case of Hawley Hospital, the fort has a central power plant which produces steam from coal. Can the hospital be hooked into that system and taken off its own system at a savings? The next step is to propose changes for the hospital. For the hospital, the proposals were the following: replacement windows with thermal pane and thermal break frame, buying a small air handler to serve the 24-hour emergency room in order that the main air handler, which served the large clinic area next to it, could be shut off except for the 9 or 10 hours that the building was occupied. 3, purchase a control device to operate the surgery air handler intermittently during the unoccupied hours rather than continuously. 4, remove 767 fluorescent light fixtures. In other cases, typical proposals are adding storm windows, insulating the attic, interior paneling with insulation, vestibules, tuck pointing, reputting of windows, caulking, sunshades on the building exterior, blocking up windows, replacing inefficient light fixtures with efficient ones, lowering the hot water temperatures, installing flow control devices on showers, adding a small water heater for kitchen use so that the water temperature can be turned down to the larger general purpose water heater, putting mechanical equipment or lights on timers so that their operation is reduced. The process of proposing changes means the specification of the nature and extent of the change. If thermal pane windows are to replace single pane windows, it means drawing enough details to see what kind of window will work and to show how the building skin is different. It means knowing the square footage of building skin that is to be changed to the new, lower U value and knowing what the change in U value is. It also means estimating the cost of the proposed change. Material, labor, and any demolition work required comprise the initial cost for the client to make this change. Now we have all the basic information needed to see what kind of energy savings can be affected by the proposed changes. We hired Mechanical Engineer Data Systems Incorporated for their computer program, which would produce an energy profile of the building. We submitted data such as location of the building, heat gains and losses, types of heating and cooling system, the fuel each used and the fuel costs, occupancy schedules, fan RPMs, and various other things. The computer would take this basic data and build it up into a composite figure of kilowatt hours and BTUs. We would check these figures against the billings to see if we were close or whether there had been an error. At the same time, we submitted the data for the existing building. We submitted the data for the changed building. If we cut lighting 50%, we so indicated. If we changed fuel source, we so indicated. If we changed the building skin, we had different heat gains and losses. Here it is important to understand the building as an integrated system. A big selling point for energy conservation studies lies in the fact that what appears to be obvious, the obvious method of reducing energy consumption, may end up not reducing that consumption. For example, some buildings are designed to lose heat at a specific rate during the winter, and if insulation is pumped into the walls, it may result in the need to cool the building in winter. It depends upon the people and the lights present. Or another example is reduction of lighting levels may require addition of heat to the space through the heating system. Understanding these relationships and taking as many as possible into account is part of what the energy study has to offer. Buildings are complex, integrated systems which the layman knows fairly little about. The architect's and engineer's expertise plays an important part in the success of the study because the computer models must be relatively accurate. Since the computer has divided its energy use between BTUs and kilowatt hours, the next step is to make a simple subtraction to find out what has been saved for each proposed change. These BTUs and kilowatt hours can be turned into dollar figures by converting the BTUs first to tons of coal or cubic feet of gas or gallons of oil, and then multiplying by the current price of the form of energy. In the Army project, where they were not concerned with such things as investments, meaning money at interest, and inflation, the operating savings is a simple multiplication of tons of coal by kilowatt hours times the cost, tons of coal or kilowatt hours times the cost of those fuels. But with clients who are subject to those facts of reality, the annual operating cost savings becomes an average annual operating cost savings taken over a specified period of years, known as the life cycle of the change. Over the life cycle, let's say 20 years, the price of fuel will escalate due to inflation and other costs and other reasons, perhaps. And the money saved each year represents money over a time period. Money over a time period is something that can be invested, so it implies an interest rate. To get the average annual operating cost savings, we discount each of the 20 years operating cost savings, which are increasing now because we have assumed that they are increasing, to the present. We sum them and divide by the number of years in the life cycle, 20. That gives us our average annual operating cost saving. The next step is to determine the payback period of each proposed change. Done simply, as in the Army's case, this is the initial cost divided by the annual operating cost savings. In the more complicated interest and inflation case, it is the initial cost divided by a modified average annual operating cost saving. Modified because the payback period is normally unequal to the years in the life cycle. Mathematically, it's a reiterative process. The final step is to take the 3 bits of information and rank the proposed changes within each. What is the order from least to most expensive initial cost? In the Army's case, removing 767 lights was least expensive. Operating the surgery air handler intermittently was second. Replacing the windows was third, and buying a small air handler for the emergency room was fourth. What is the order from shortest to longest payback period? In the Army's case, the lights were first, with 10 months. The surgery air handler second, with 3.5 years. The emergency room air handler with 5.6 years, and the replacement windows with 62.3 years. What is the most to least operating cost savings? In the Army's case, once more, the lights came in first again with a savings of $9,388 per year. The emergency air handler moved up to second with a savings of $4,143 per year. The surgery air handler moved to third with $3,474 per year, and the windows came in last with $229 per year. When you are finished with all that, you produce a report, and with that information, the client can then determine his course of action. That concludes the study method. It's been my pleasure to present it. Questions? It's sort of technical, I realize. I might say that replacement windows normally came out bad in every case. Storm windows came out usually quite well, but when we were there on the fort, we would notice that half the time they were up. In the winter, they would need some fresh, so they would put that outer window up when they would raise the inner window, and then they'd forget to put that back down. So we didn't recommend that because we didn't feel that they were really doing what they could.
Did you guys go one step further and analyze the information, and then, like you showed, the payback time and stuff like that, and obviously the windows, it wouldn't even be worth changing because that building complex might not be existing in 62 years.
Yeah, right.
So if you go one step further and analyze, make recommendations as far as what we would.
Yes, we did.
Better changes.
This young man asked whether or not we went one step further than just ranking them there. We did, because what we did, we had a section where we recommended the changes they should take. And we cut the payback period off at 25 years, which we still thought was quite long. But that's where we cut it off. And so anything that fell over that, we didn't do. Now, there were a lot of other changes that we would propose that could be done by the people at the fort. And so there was no initial cost to speak of. So we would recommend those under a section we called in-house changes, and they wouldn't come up in they wouldn't appear in the final ranking or in anything to do with allotting projects to these $1 million buckets for 5 years. We had done, the question ask is whether this is the first study we had done of this kind. We had done other studies, but much less formally. We were forced into formalizing this process because of the volume, the magnitude of it. And just the printing of the reports and so forth, I mean, there were 4,000 pages in it, and all of this information had to be organized so that when it came out, you know, it looked like that it was organized. So we had computer printouts, which were, you know, putting forth their information in the right margin settings and all this type of thing, many types of things like that. And initial data sheets we would organize right from the start so that we could just lift them directly to the final report. We'd have the margins all set and the titles and so forth. We've done several studies since. 2 post offices in Kentucky and the Masonic Home.
Have these studies and reports all been these types of fairly elaborate computer-aided things, or do you have a simplified version that would be used for a simpler project, or which is a less fully resourced office that yours could use?
Well, I'm not really prepared. Excuse me, I keep forgetting to reiterate the question here. The question was, is there a simpler process which an office which has less resources, staff-wise, can use to make similar but less sophisticated studies? I'm assuming that's what the question. I'm really not prepared to answer that. I asked the question of the mechanical people for my own house, and they gave me things like block load sheets and that type of thing, where they have to know what the U value of that house is. The U value of that skin. You can do the same thing yourself and then change it and so forth on a less sophisticated basis. Sometimes we would get in a pinch with the computer printout too. It would be wrong, and maybe we had to have a particular part produced, and so we would have to do something on that order.
Have you ever considered or included in the evaluation change in sign modifications? Sign modification.
The question is, did we include in our evaluation changes in sight? I'm assuming planting trees, any? No. The question was the engineering done in-house or did we hire a consultant? The engineering was done in-house. We did hire the computer program. MEDCI. I gave the name of it here. Whatever MEDCI stands for. Mechanical Engineer Design Consultant Incorporated or something like that. I can't tell you. No, I don't think so. I can't tell you what it is.
Did I notice that the conservation program started in 1980?
Yes. Oh, excuse
Why did they decide to wait till then and get your cost figures taken into account that it was starting over that time?
Well, the question was why we said that they planned to go ahead with this in fiscal year 80, and the question was why wait that long, and did our figures take that into account? The reason they have to wait that long is they are planning right now for fiscal year 80. They couldn't hurry it up any faster. I mean, they couldn't get it into a year ahead of that because the process, that's just the process. I mean, they would have had to bid last year to get it a year ahead, so they just couldn't do it. And our figures, we put everything as of the date of the report, which was April 15th. And so any increase in the figures is on their part. Now, we found we had projects which we could only find enough projects to spread over 3 years, and every year was less than $1 million. We couldn't spend the money that was allocated for it.
What did you find a study of this type, this pretty comprehensive study? What did you find in the study cost or exceeding potential savings on a lot of those?
What did you say?
What did you find with the potentially study cost, if you could apportion the cost to the particular defect study, what did you find with the cost of the study would exceed a lot of what you're finding in terms of potential savings?
It could, but it doesn't in this case because, oh, excuse me. The question is, would the cost of the study in many cases exceed the savings from energy conservation? It could do that. It isn't the case here. I mean, they'll save more than that, I think, in the first couple of years once they do the first projects, because the first projects tend to be quite large. Also, as a matter of policy, what we do at McGuire & Shook is, if somebody's interested in energy conservation study, we will go and look at their building and bill them for the hours we're there, part of a day normally. If we see that we can save them money, save them more money than what we would charge them for the study, then we will tell them they need the study, but we won't tell them they need the study unless we can do that. We like to sell it based on the fact that their energy savings will pay for the study, and it makes it a lot easier to sell.
In your recommendations, did you accept the space uses that existed, or did you make some recommendation for a modification, a functional modification of the building?
Let's see. We accepted what they used it for. We did not make those recommendations. There were cases, the Army, especially in the Army Finance Center, that area changes a lot. I mean, there's someone moving in and out of that place continuously. So you get some types of, well, most of the stuff is office stuff, which is no big change, but you will get some things like computer. They'll turn one whole section into a computer area, and so you will get a large change like that. But we didn't know, we weren't able to take that into account, nor recommend anything one way or the other. Any further questions? Okay, thank you very much.